Hey guys, in this tutorial we're going to make an Arduino push button piano using 8 push buttons. And if you have a look at the fritzing diagram, this is how it is supposed to look. Alright, so that's the diagram, and we're going to also use mBlock 3.4.12 to do the coding. And we're going to use a few extensions that I've written as well to make the coding a lot easier. Now, without further ado, let's begin. So we have all the pieces here. We have the breadboard, full-size breadboard. We have the 8 push buttons. We also have the caps to put on top of the push buttons. We have the jumper wires, long and short. We need 8 10k ohm resistors for the push buttons. We also have the Uno board. Right, so we are going to start putting this contraption together. Okay, so let's begin. So we're going to start with this one. We're going to put the buzzer so the positive part goes on the left and the negative will go on the right. Now, I am going to connect, so I'll just move all this slightly. So I'm going to connect the jump wires to the Arduino board. So we need 5 volt. So plug that in. A positive rail. And this part goes into the ground. Okay, there we go. Now the next part is we need to get all of these connected. So let's get started. Right, so let's just jam these in. So we need 8 of these. And also keep in mind, because the breadboard, the full breadboard, there's one half here and there's one half there, so we're going to have to bridge the rail. Because we're not going to be able to fit all this on half a breadboard, which is why we use a full one. So at most we can fit about 4 or 5 of these buttons, but we need 8. Okay, in any case, let's get these connected. Good. So 8 push buttons. Now we want the cap. So let's put the caps on. Right, that'll do. So it's going to be C, D, E, F, G, A, B, C. Okay. Now let's, what do we need to do now? Oh yes, we need to to connect these, and we need to connect some of these red jump wires. We also, we need to connect the speaker, I think. That's important. So let's get the black wire and plug that to the negative, which should be here, so we need to go down there. I believe it's there. If it's wrong, we can switch it. So put it into the negative rail. Okay, good. Now let's get the rest done. So just got to follow the diagram. All right, just make sure so that has to follow. So we're going to plug that. So plug that there. Just keep doing it for each one. What I might do is I might just plug them in first before I put them into the rail down at the bottom. At least I know they're in the right place anyways. Okay. So I'll just put this aside. We'll get the resistors done soon. You need specifically a 10k ohm resistor for each push button. That is very specific. Okay, so there we go. We've got that. Now we have to just connect each one to the positive rail. That looks good so far. The only problem is, like, if I try to play and then these cables kind of get in the way, so perhaps there's a better way to organize the cabling. Yeah, I think it's because the cables are sticking out, so if I try to play this like a piano, this is going to obstruct my hand. So I'm just trying to find the best way to do it. I mean, ultimately, just use whatever works for you. So, I mean, as long as you can get it to work, everything else is secondary. So just make sure you can get this thing to work. All right. You can get cables that are flat. I mean, these are not the most ideal, but at least you can still kind of reach over and play. So. Okay, we'll sort it out later. We'll make it better later. All right, so that we've got that. Now we need to prepare the resistors. So we've got 8 10k ohm resistors. Okay, let's take these out and let's plug these in. So we should have one resistor for each push button. Alright, I'm not going to start cutting these resistors. I'm going to just bend them and put them in accordingly. Because I don't want to keep using black wires, I'm going to plug the resistor directly into the negative rail. So let's just make sure we can get it. It's going to be very cramped right now because there's a lot of wiring going on. So we'll see how we can get this done. Just see how far we get with this. Yeah. Make sure you plug it into the right rail. Eventually I will snip these ends of the resistor so it doesn't stick out so far. I just want to make sure it works, and once I realize it works, I will trim down the resistors and make them shorter so it doesn't obstruct my hand later. But for now we'll just make do with this. So we just keep adding the resistors. Okay, we've got 3 more. All right, that looks correct. Good. Okay, we've got all the resistors and we have all the positive wires. Now, what we want to do now, if you look at the fritzing diagram, we are going to assign each of these buttons to a digital port at the top. And each cable, for intents and purposes and also to help us, we're going to use different colored cables for each button or each note, so to speak. All right, so we've got to make sure we have to plug it. So if you look at the top, we have to plug it on the right, a bit on the right like that. So you have to, so there's 8 of them. So we just plug it like that. Okay, number, just jam it in there. So we'll put the colors in first and we'll worry about the rest later. So we'll just put this in. I'm going to try and use the exact same colors as the fritzing diagram, just it does help. It's also good for the students, but the students need to also realize that the cables, even though the exterior is a different color, the cables are virtually the same. The color's just for us, so we can remember like easily like which color is for which button and so forth. And by default, we normally use red for positive and black for negative. It's just something that we're used to with Arduino. Anyway, and some people use white for the negative, but I prefer to use black. So there we go. All right, so, oh, hang on, I think I've missed a note. Oh, sorry, no, that should be yellow. So we'll get the yellow in there. But make sure I don't get the wrong one. So, okay, let's put that in there. And, okay, there's the yellow one. And this brown one. Okay, brilliant. Wow, I mean, that is quite a contraption. It's not the prettiest looking thing, but as long as it's functional, that's all that matters at the moment. Okay, so now, so we're going to go from 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we start with 5. So we plug this into 5. Just make sure we get the right one. Okay, 5, and then 6, and we'll just keep going. Let's move this a bit so you can see. And 7. I have to make sure in my program I get the pin numbers right, otherwise it's going to be a right mess. Oops, oh, I've just bent that. These things are a bit fragile. Okay, number 8. green is number 9. And number 10 is the yellow. Number 11 is orange. And number 12 is brown. Well, that is rather something. Yeah, we're gonna have to clean up these cables soon because it's really hard to get in there. And the buzzer. Oh yes, we haven't connected the buzzer yet to the digital port, so we will do that. I'm going to probably just use a red wire to get that done, even though it's a different color on the fritzing diagram, but that doesn't matter. So it should be the positive, so it should be there. Yeah, it should be there. And then we want to plug it into number 3. So 0, 1, 2, 3. There we go. All right. Oh yes, and one other thing I nearly forgot. We have to bridge these two halves as it's shown on the fritzing diagram. So we need to bridge the negative rail from here to here and bridge the positive from here to here. So we need a cable to plug the two ends together. So we'll just take any part of the positive rail and just plug it into the other half of the positive rail, just like that. And we do exactly the same for the negative, because what will happen is like these notes will work and then these won't. So we have to make sure we get that sorted. It's important that we have to get everything plugged in correctly, otherwise it will not work the way we intended to work. Okay, so let's just get that in, and there we go. Okay, now we're going to start coding this thing, and to do that we're going to use mBlock 3.4.12, as you can see in my example. So this is it, and what we need to do is we need to, in order to program the buttons, we need to download a special extension, and I have made this and I've put it on GitHub. Now, in order to get the extension to make the coding of the buttons easier, we simply go to Extensions, Manage Extensions. All of the extensions that you can download for mBlock 3 are all here. You can search for them, or you can just scroll down and find the one that suits you. All the extensions that are currently installed, for example, Arduino, Orion, MegaPi, mBot, which is popular with the kids at school, are all there. My extensions have my initials PCM. So if I type in PCM, and I've got a Bluetooth HC05 add-on, I also have one for HCSR04 and Arduino push buttons. So that's the one we want. So we want to download that and then close that. Okay, and we also want to connect our contraption to the computer with the USB cable. Now make sure mBlock is connected, so you want to connect the serial port. If you've got a Mac, it's going to be USB modem 14501, or if you have a PC, a Windows PC, it's going to be a COM port. So we know it's connected when the light is green. Also, please make sure you choose the right board. Okay, this is not an mBot. Go to Arduino Uno, and you get the appropriate blocks for Arduino Uno. Because this is Arduino, we need to drag in the Arduino program, and we'll just put the code listing there for intents and purposes. Okay, now let's start off with the basics. Before we get into variables and stuff, let's just go into the basics. Now, the first thing we want to do is we want to say, we want to check whether the button is pushed or not. So we're going to use, from my extension, check push button number 1 on state on pin 1. Now we know that the first button, which is this one, is connected to number 5. Okay, so push button 1, so we have to declare that push button 1 is on pin 5. And eventually we will copy this a few times. We need 8 of these for each button for each pin. All right, so we also need a forever loop, and we need an if-then. We also need an operator. Okay, something equals something. We can make it bigger just so you can see that better. All right, now let's have a look. So forever. First, we need to check that the button is pushed or not. Now, 2 numbers you have to remember, 1 and 0. If I push the button down, that's a 1. If I let go, it's a 0. So we want to say that when the push button, the state detects a 1, we want to play music from the buzzer. In this case, we want to play a C note. So we're going to play C, D, E, F, G, A, B, C. To play the notes, it's already built in the Arduino extension here. So if we go to play tone on pin, and apparently it should be, if I can just double check again, it is pin 3. So change the tone for the buzzer to pin 3. Okay, we're going to go, by default it's C4, so we're going to go C, D, E, F, G, A, B, C. That's 8 notes. And we're going to have quarter. So we shove that in there. Okay, what goes in there? Here. If the state of the push button, the first push button, is pushed, then we play the tone. Right. That is the program for the first button. So now we have to upload it. So just wait for that to upload. Okay, there we go. And now we can push the button. There we go. If we want to make the tone go on for a little longer, we can change the beat from, say, quarter to half or whole. If we try half, let's see what happens. It will play longer, but I prefer to have the notes a little quicker. So now if I press the note, yeah, it's a little longer. Sometimes you want to play notes really quick, and it's not good to have it so slow. So let's have quarter. Or if you want, you can go for eighth. It's entirely your choice. So let's upload again. Good. Now, what we want to do now is we want to copy this. We want to set the push button, each push button. So we have push button 1, 2, 3, 4, 5, 6, 7, and we need one for 8. Okay, in total we have 8 push buttons. We could put this into a function, but I'm not going to do that for now. For now, I'm just going to do the basic programming. So there we go. So 1 to 8. Yeah, make sure you get the right pin numbers. So 5, 6, 7, 8, 9, yeah, 10, 11, and 12. Okay, so there we go. Those are the pins, all aligned to each respective push button number. Okay. All right, so this is where it's going to get a little bit long. So what we have to do is just copy. We have to copy this a few times, so it's going to get quite cluttered. Normally we would use functions, but I'm not using them at the moment, so I just want to demonstrate to you. I just want something that works. Okay. Let's see, so we need to copy that. All right, so yeah, so keep that. All right, so 1, 2, 3, 4, 5, 6, 7, and 8. You can have up to 10 buttons. Oh, and another thing, make sure that each note is different. You don't want C4 playing each time, so you want the first one, the first button to be C4, and the next one to be D4. So you keep incrementing each time. So C, D, E, F, G, A, B, and this has to be C5, like the next octave. Okay, now let's upload and let's see what happens. So all this code is going to go right into the Arduino board, the Uno board. Okay, let's see if it's worked. So we'll do the C4 and then the next one. Perfect, it works. All right, so we can play a little tune. We only have major keys. We haven't put in any of those black minor keys. Right now we're just focusing on the simple stuff. Eventually we might be able to make it have so it's like an actual full-size keyboard, because we are restricted because we don't have all the notes, obviously. Anyway, that is your basic keyboard. Something that we could do as well, because you'll notice that the code looks very cluttered, especially this part here. What we could do is put this into a function. So in order to do the function, if we go to make a block, and instead of saying push button 1, 2, 3, 4, 5 all the way to 8, we could just we could have a function called check all buttons, one word, capital C, capital A, capital B, check all, or CAPB. More like check all push buttons. Okay. All we have to do is just take this bit out and then just bung that there. So when we start, just once we get into the forever loop, we have to call the function check all push buttons. So we have to take that and put that there. All right. Let's save that and let's see if that works. Right, let's play London Bridge is Falling Down. Oh, I missed a note, but never mind. Okay, so that is a function. Right, it's a lot more efficient that way. A lot more efficient. All right, so that is the Arduino 8-button piano, created with Arduino components and with mBlock 3.4.12 with my own extension. So thank you so much for watching, and we'll see you soon. Take care and goodbye.